This is Algebra 1, Lesson 26, More Complicated Equations. We're going to be doing examples 26.1 and 26.2. What a title, right? In the last few lessons and videos, we've been learning some different tools that you can use to solve equations, like the additive property of equality and the multiplicative property of equality. And we understand the idea of an equation that both of the expressions on either side are equal to each other. And as long as we do the same thing to both sides, we will end up with an equivalent equation that has the same solutions. So we can use that to help us solve and find the value of x. Now, a couple examples into this lesson, the Saxon textbook is going to give you some steps to solve equations, and I went ahead and wrote those here for you. Let's look at those steps now. Number 1 is to simplify by adding like terms that are on the same side of the equal sign. So let's look at this example 26.1. We're going to look at this left side of the equal sign, and notice that we have two terms. Here's a term, a subtraction sign, and another term. Those terms are not like terms, so we cannot combine them. Let's look at the other side of the equal sign. We also have two terms separated by a plus sign. They are not like terms, so we cannot combine those. So we're off to a good start. Okay, we've accomplished step 1 because you couldn't do that with this equation. Number 2, eliminate the variable on one side. So we want it to go away. How could we make the 3x go away? Well, we could subtract it and it would go away. But now we don't have a balanced equation, so we would need to go to the other side and subtract 3x as well. Now, your book will write it like this. They'll show the line all the way across, just showing that they are subtracting from both sides. I typically just draw a shorter line. It's just a habit from the way I learned it. Now we're going to bring down what is left on the left side, and that's just the -4. Don't forget that negative in front of it. You may say, wait, that's a minus. Yes, it is, but remember, subtraction's the same as adding the opposite. So we could think of it here as a negative. That's equal to 5x's minus 3x's is 2x's. Bring down the plus 7 because it's left. Okay? Now, you may say, well, why didn't we get rid of the 5x? Well, we could have, but we chose to get rid of the 3x, and it says eliminate the variable on one side, and that's the choice we made, and that's fine. In the second example, I'll show you what it would look like if we had eliminated the 5x. Let's look at step 3. Eliminate the constant term. A constant is just a plain number, right? Eliminate the constant term on the side with the variable. So here's a constant term, but it's not on the side with the variable. Here's a constant term, and it is on the same side of the equal sign with the variable. So we want to get rid of plus 7. So we'll do the inverse operation and subtract 7. It'll go away, but we need to quickly come over here and balance. Now, careful right here. This means -4 minus 7, or you can think of it as -4 plus a -7. Okay, that's what this means. So be careful when you compute it. If I go back 4 on the number line and then back 7 more, I'm back 11. And that equals 2x. Now, I have taken care of step 3. Step 4 says solve for the variable, and we know that solve means get the variable by itself. The x here has a 2 in front of it. That means it's being multiplied by the 2. So if I want to get rid of that 2, I'm going to need to divide by it. On both sides, that will cancel out. 2 divided by 2 is just 1x. And our answer is -11 halves, which is -5.5 or -5.5. All of those are equivalent. But for our purposes, it's fine to leave it as an improper fraction. Now, if you took that value and substituted it in, you did 3 times that minus 4, and then you did 5 times that plus 7, you'll find out that both of those values are equivalent. Okay? And that'd be a neat thing to do on the calculator if you'd like. So we did step 4. These are the steps we're going to use for all of these problems. Let's do one more on this video, and I copied the steps again there for us to be able to refer to. All right, simplify by adding the like terms that are on the same side. Term, term, this is the same as the last problem, right? Two terms on both sides, none of them are like terms, so this is taken care of. Eliminate the variable on one side. When we did it in example 1, we got rid of the 3x by subtracting. Let's say we choose to get rid of the 5x because it doesn't tell us which one we have to do. It just says eliminate the variable on one side. So let's get rid of the 5x. We'll subtract to make it go away because 5x minus 5x is gone. Let's balance it. 3x's minus 5x's would be negative 2x. Bring down the minus 4 equals positive 7. Eliminate the variable on one side. We did that. Eliminate the constant term on the side with the variable. So this time, the minus 4 or negative 4 is on the same side as the variable. We will have to make it go away by doing the opposite, which is adding 4. We get negative 2x equals 11. Took care of that. Now we're going to solve for the variable. They're multiplying by negative 2, so let's divide by negative 2. X is going to be equal to negative 11 halves, which is exactly what we got in the last example. So you can see, even if you choose to start by eliminating the other variable, that's okay. You'll get the same answer.